All right, lesson 6.6, trapezoids and kites. So in this lesson, we're going to talk about the two other types of quadrilaterals, and these will have different properties than we had for the parallelograms. The first thing about trapezoids, they're not parallelograms. So the second part, trapezoid has one pair of parallel sides called bases. The sides that are not parallel are the ones that called the legs. And in an isosceles trapezoid, the legs are congruent. And just like a triangle, we have a midsegment for a trapezoid, and that midsegment is the segment that connects the midpoints of the legs of the trapezoid. So once again, they're not parallelograms. They have one parallel sides called bases. Sides are not parallel are called legs. And in an isosceles trapezoid, those legs are congruent. And the midsegment of it is a segment that connects the midpoints of the sides of the trapezoid. That you can have a midsegment of a isosceles trapezoid, and you can also have a midsegment if a triangle or if the trapezoid is not an isosceles trapezoid. So the isosceles trapezoid theorems. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent, and its diagonals are also congruent. So base angles are the ones that surround your two parallel sides called the bases. So these two right down here are going to be congruent, and these two right here are congruent. You can think of this as an isosceles triangle with the top cut off. Our base angles would be congruent, therefore these would be congruent as well. And the reason for this, if you remember, anytime you have parallel lines and you have another line intersecting it, it creates special angle pairs. So we're going to have same side interior angles. And these are same side interior angles. So remember that in same side interior angles, they are supplementary. Now, the other thing is that the diagonals going from T to A and from R to P, those will be congruent only in an isosceles trapezoid. Okay, so these are properties of just an isosceles trapezoid. So now let's look at the trapezoid midsegment theorem. So if a quadrilateral is a trapezoid, then two things happen. The midsegment is parallel to your bases, so these all three are parallel, and it's equal to half of the sum of the two bases. So in a triangle, remember the midsegment was half of the third side. This is going to be half of the sum of the two parallel sides here. So in this case, the length of MN is equal to half the length of TP plus the length of RA. So let's take a look at this. CD is an isosceles trapezoid. The measure of angle C is 65. What is the measure of angle DE and F? So as you recall, we talked about if it's an isosceles trapezoid, the base angles are the same. So these two are the same, and these two are the same. So this would be 65 here. Now, in order to find angle D, we would have to remember that these are same side interior angles, which means we'd subtract from 180. So 180 minus 65, that gives us 115. So this is 115, and because our base angles are congruent, then this side over here is also 115. So angle D is 115, angle E is 115, and angle F is 65. So, in the diagram PQRS, it's an isosceles trapezoid. The measure of angle R is 106. What is the measure of angle P, Q, and S? So pause the video, find your measure of each angle, come back and check your answers when you're done. All right, so if we look here, angle P is going to be a linear pair with angle, or not a linear pair, but a supplementary with angle S. Since this is an isosceles trapezoid because of these two congruent marks, that means that the two base angles here are the same, 106, and therefore these should be the same. So to find angle P, we subtract 180 minus 74, 180 minus 106, and that gives us 74. Now, angle S is going to be 106, and angle Q, which is also a base angle with angle P, is going to be 74. So now, if this triangle was not an isosceles trapezoid, would angle Q and angle R still be supplementary? Well, so no matter what, anytime we have a parallel line and a transversal, we're going to create our special angle pairs. So these are going to be same side interior angles no matter if these are going to be congruent or not. Which means the answer would be yes, they're still supplementary because they are, like I said, same side interior angles. So let's take a look at this. The second ring of the paper fan shown consists of 20 congruent isosceles trapezoids that appear to form circles. What are the measures of the base angles of these trapezoids? So in here you see this is an X, this is a Y, and this angle 1 up here. So to give you a better idea of what we're looking at, I'm going to draw what we have up here. Now, so this right here consists of, there's our angle 1, we have our X down here, and this is going to be Y degrees here. So they said that they form isosceles trapezoid, which means that this would have to be the same as this. That also means that this is the same as this, which means we have an isosceles triangle here, and we have a big isosceles triangle, because since these two are the same, then these two would be congruent. Now, how do we find angle 1? Because we don't have any other angle measures other than the fact that we know there are 20 of these around this figure. So the first thing we do is we have to figure out what does this measure this angle right here. The way we do this is to recognize that this angle is around the center of this. So there are 20 equal ones. So if we took 360 and divided by the number of triangles that can be made, which is 20, then we will get our answer to become 18. That means that angle 1 is 18 degrees. So once we know 18, then we can work it like it's an isosceles triangle. We know these base angles are the same, but we also know that these are going to be the same as those because they share a common vertex angle. So to remember, as we find this, we take 180 minus 18, and then we divide it by 2 because we have to split it between the two base angles. That is 162 divided by 2, which gives us 61. So this is going to be 81. So this will be 81, and this will be 81. Now, because of these lines being parallel, then that creates a special angle pair here, which means these are corresponding angles, so x is equal to 81. Now, for y, notice that 81 and y form a linear pair. This forms a straight line. So to find y, we're going to do 180 minus 81. It means that y is equal to 99. So we have our two values here. X is 81 and y is 99 degrees. So the central angle, find the base angles for that vertex angle here of an isosceles triangle, and then use the linear pair postulate to help determine that these are supplementary. So let's look at the next one. Let's say we change, instead of having 20 of these, now we have 15. So find the value of x and y, given that there are 15 of these trapezoids instead of 20. All right, so we find our central angle here, angle 1, by doing 360 divided by 15 now, since we have 15 angles. Gives us 24 for our vertex angle. Subtract it from 180, divide it by 2, gives us 78, which means that x is going to be 78 and y is going to be supplementary, which means it's going to be 102. All right, so let's take a look now at example 3, finding the midsegment of a trapezoid. So if you go back and look at the equation, it says that we are going to find our midsegment is equal to the half times the sum of our bases. So let's call this x, my midsegment. X is equal to 1/2 of 18 plus 24. So 18 and 24 gives us 42. and half of 42 is going to be 21. So one thing you can determine also from this is that 18 is 3 from 21. So 24 is also 3 from 21. So they're split the difference here. So let's take a look at the next one. Find this other base, given the mid-segment now, and one other base. So most of you guys have probably done this in your head. You can realize that this is 7 from 30. So it's 7 above. That means that this one has to be 7 below. So we're going to add 7 to get that one. We're going to subtract 7 to get this, which is 23. So the other segment would be 30 minus 27, which is 23. But now let's look what happens when we work this out with a variable expression. QR is the mid-segment. LM is one base, PN is the other base. So from the equation earlier, it would let us to conclude that QR is equal to 1/2 the sum of my bases. Well, one base is LM and the other base is PN. So one way to solve this and get rid of the half in the problem is to multiply our expression by 2 on each side. So each expression gets multiplied by 2. That cancels the 2 on the right, leaves us with LM plus PN, and then we get 2 QRs. So now when we go back and plug our expressions in for our variables, then we know how to set it up. We know it's set up correctly. So 2 times x plus 2 is equal to 4x minus 10 plus 8. So begin by distributing. 2 times x is 2x, 2 times 2 is 4, equals 4x, and then I would do negative 10 and a positive 8 would be a negative 2. So next is to solve for our x. So subtract 2x, add 2, 6 is equal to 2x. Divide by 2, and x is equal to 3. So once we get the value of x, now it asks us to find and plug these in. So x equals 3. LM is going to be 4 times 3 minus 10. 12 minus 10 is 2. So this one's going to be 2. And then for QR, we're going to get 3 plus 2, which is 5. So we got 5 here, we got 2 here. Notice that 2 and 5, the difference of these two is 3, and the difference between 8 and 5 is 3, so we know we did it correct. All right, so you guys try the next one. Find the lengths of MN and PS, and find the value of x.